The first example in logarithmic differentiation has a very short solution. Check it out here in differential calculus. We are to differentiate the function y as equated to ln of sine of the cube root of x. Since the outermost operation is the natural logarithm ln, we use logarithmic differentiation for our initial solution. The derivative of ln of u is 1 upon u, with du over dx from chain rule. Since u is sine of the cube root of x, y prime is then 1 upon sine of the cube root of x. Then from chain rule, we attach the derivative of the smaller term, sine of the cube root of x. A trigonometric function is involved, so we employ trigonometric differentiation. But first, convert the radical sign into a fractional exponent, so we can manipulate the expression. Now, the derivative of sine of x raised to 1/3 is cosine of x raised to 1/3, with the attached d over dx of x raised to 1/3 from chain rule. This time, we have a smaller term to differentiate using power rule. The derivative of x raised to 1/3 is a third of x raised to 1/3 minus 1, which gives negative 2/3. Then again, dx over dx appears as required by chain rule. With dx upon dx taken as 1, the derivative of sine of cube root of x is then a third of x raised to negative 2/3 with cosine of x raised to 1/3. This makes the whole y prime as 1 upon sine of the cube root of x with 1/3 of x raised to negative 2/3 times cosine of x raised to 1/3. Place x in the denominator to avoid the negative fractional exponent. Then convert 1/3 as a radical, making it cosine of the cube root of x. Rearrange terms and get y prime as cosine of the cube root of x over 3 times the cube root of x squared with sine of the cube root of x. Now look closely at the trigonometric functions. Cosine all over sine is one of the quotient identities, and this is equal to cotangent, thus reaching the final answer of y prime as cotangent of the cube root of x upon 3 with the cube root of x squared.